you say that.
Okay, everybody, we're here on the 9th of May, and...
Hey, this is a day that we were predicted for something to happen with on our presentation a month and a half back, so far.
Okay, so maybe we should look at the
Yeah,
news.
May 9th, and the other one was April 17th, if I remember right.
Interesting.
But anyway.
So we'll look into that, but for now, we're going to show you a little bit of video, like about 5 minutes?
Yeah, about 5 minutes.
And then we're going to comment on it, and it relates to some of the research Roger's been doing with coronal mass ejections and solar storms and things like that. It's informational.
Well, I'll give you a little introduction about. You're going to hear it from the American Indian guy that's going to be listening to the Asian guy over here, which it's a good way to. And he's honest about it. He says that right to your face, it's going to let you know things that your scientists are withholding and your political leaders aren't letting you know about, and what's going on with the real scientific research that they're burying, and about really how much time you have to get ready for any kind of these solar storms. And so that's why I'm going to do this little intro part to let this guy explain, the situation. And then what I'm going to do after this, because of the 11 minutes, I'm going to give you a demonstration. It's not going to be a long one, of how I came up with the geomagnetic storm that we did on this presentation for 2026. Not only that, I'll even show you how I can do for future geomagnetic storms that are occurring still down the road, that are still going to happen in 2028 and 2032, which is a lot more advanced notice than 11 minutes.
Okay, so let's turn to...
Okay, Mr. Asian guy, you're on.
11 minutes. That is the total amount of time standing between a solar shockwave traveling at over 2,000 kilometers per second in complete, unrecoverable collapse of the global power grid. Not hours, not days. 11 minutes from the moment scientists detect it to the moment it hits. And right now, the sun just fired. The shot is already in transit. A coronal mass ejection, a billion-ton cloud of magnetized plasma, is moving through space at speeds that make anything humanity has ever launched look like it's standing still. And the only early warning system Earth has is a single satellite, older than most smartphones, running on borrowed time with no backup. That satellite is called DS-COVR. And if it goes dark before that shockwave arrives, nobody gets a warning at all.
Or blown up by
you're going to understand something that
storm.
Almost no one outside of NOAA and NASA knows in full detail. You're going to understand why 11 minutes is not enough, why the infrastructure protecting 8 billion people from the most violent force in the solar system is held together by a single point of failure, and why the people whose job it is to protect us know this, and have known this for years. But there is one number buried inside the DS-COVR mission data that the agency has never led with in a press release, a number that changes what 11 minutes actually means in practice, what it means for your city, your hospital, your water supply. We are going to get there. But first, you need to understand what is actually heading toward us right now and what it is capable of. Because the last time something like this hit Earth with full force, it happened before any of this infrastructure existed, before satellites, before power grids, before the internet. And scientists have spent over a century calculating what that event would do if it happened today. The number they came up with is not something any government has made a headline of. Stay with me. The sun is not a stable object. It is a churning, magnetically unstable ball of plasma that cycles through periods of relative quiet and extreme activity roughly every 11 years. We are currently inside what scientists call solar cycle 25, and it has been running hotter and more active than any predictive model forecast. The number of X-class solar flares, the largest category on the scale, has exceeded projections by a significant margin. Coronal mass ejections are not the same as solar flares, though they often travel together. A solar flare is radiation. It moves at the speed of light and hits Earth in 8 minutes. There is no warning possible for a flare. It arrives before the light that would have told you it was coming. A coronal mass ejection is matter, magnetized plasma. It is slower, which is why we have a detection window at all. But slower is relative. The fastest CMEs ever recorded have traveled at over 3,000 kilometers per second. The 1859 Carrington event, the most powerful geomagnetic storm in recorded history, produced a shockwave that crossed the distance from the sun to Earth in roughly 17 hours. Modern fast CMEs have done it in under 14. The event currently under observation is moving at approximately 293 kilometers per second. that puts Earth impact somewhere in the range of 15 to 60 minutes after DS-COVAR detection. DS-COVAR sits at a point in space called the L1 Lagrange point, a gravitational sweet spot approximately 1.5 million kilometers from Earth, directly between us and the Sun. At that position, the satellite essentially hovers in place, held by the combined gravitational pull of Earth and the Sun. It watches the solar wind constantly. When a CME arrives at L1, DS-COVAR measures the magnetic field orientation, the density, the velocity. That data is transmitted to NOAA in real time and gives grid operators their warning window, 15 to 60 minutes. On a good day, with the satellite functioning, with the data stream uninterrupted, with the magnetic field of the incoming CME oriented in the worst possible direction, southward, which drives energy deepest into the magnetosphere, the operational response window shrinks toward its minimum. Power grid operators have stated publicly that they need a minimum of 15 minutes to begin protective shutdown procedures. Satellite operators need 30. At the lower end of the DS-COVAR window, neither is achievable, but that is the scenario with the satellite working. Here is the scenario without it. DS-COVAR was launched in 2015. Its intended operational lifespan was 5 years. It is now operating more than 6 years past that design life. The satellite has experienced multiple anomalies. In 2019, it entered safe mode due to a hardware fault and went offline for months. NOAA was forced to use older, less capable backup systems during that window, systems that provide less accurate magnetic field data and longer processing delays. That was during a period of low solar activity. This is not that. And the question that should be keeping grid operators up at night is not whether DS-COVAR will eventually fail. It is whether it will fail during an event exactly like this one. Stay with me, because what comes next is where this stops being a space story and starts being something else entirely. Here is what a major geomagnetic storm actually does to infrastructure, and why the warning window is the entire ballgame. When a CME with southward-oriented magnetic field reaches Earth, it interacts with the planet's own magnetic field and begins driving enormous electrical currents through the upper atmosphere. Those currents induce voltages in long conductive structures on the surface, pipelines, rail lines, and most critically, high-voltage transmission lines. The transformers that sit at the nodes of the power grid, the massive building-sized units that step voltage up and down across the transmission network, are the most vulnerable component. They were not designed to handle geomagnetically induced currents. A severe storm can drive enough induced current through a large transformer to overheat and destroy the internal windings in minutes. These transformers are custom-built. They are not items that sit in a warehouse somewhere waiting to be swapped out. Lead times for replacement units run between 1 and 3 years. A single failed transformer can take down power to hundreds of thousands of people. A coordinated failure of dozens of them, which is what a Carrington scale event produces, is a different category of problem. In 2008, the National Academy of Sciences released a report estimating the potential impact of a severe geomagnetic storm on the United States. The figures in that report were not written for headlines, which is probably why they never became headlines. The estimate was that a major storm could cause $1 to $2 trillion in damage in the first year alone. Recovery time was estimated at 4 to 10 years, not weeks, years. That estimate was based on 2008 infrastructure. The grid has grown more interconnected and more digitally dependent since then, not less vulnerable. The Carrington event happened in September 1859. The geomagnetic storm it produced was so intense that telegraph operators reported receiving electrical shocks from their equipment. Some telegraph lines continued operating after operators disconnected the batteries entirely, running purely on the induced current from the storm. Aurora were visible as far south as the Caribbean. If that same event struck today, the electromagnetic environment it produced would be indistinguishable from a global EMP scenario in terms of grid impact. The transformers go first, the grid follows, and everything that depends on continuous electrical power follows the grid. Hospitals have backup generators. Those generators run on fuel. Fuel supply chains depend on electrically powered pumping infrastructure. Water treatment plants have backup systems. Those systems are not designed for multi-week outages. Data centers have UPS systems. Those systems measure runtime in hours, not weeks. The cascade does not require a single catastrophic moment. It requires sustained loss of primary power to critical systems that were designed assuming restoration timescales of hours to days, not years. What does any of this have to do with DS-COVAR in 11 minutes? Everything. Because every protective action available, grid operator shutdown, satellite safe mode, pipeline protection protocols, every single one of them is time dependent. The infrastructure to survive the storm exists. The procedures exist. The trained personnel exist. The only thing those procedures require to function is time. And the only thing standing between the storm and the clock is one satellite that is operating past its expiration date with no confirmed replacement. There is a replacement mission called IMAP. It launched in 2024, but it is a science mission. Its space weather monitoring capability is limited compared to DSCO-VR. The operational gap is real, and it is not closed. Here's the part of this story that nobody seems to want to say clearly. The scenario where DSCO-VR fails during a major CME event is not a fringe risk. It is not a tail risk thought experiment buried in an academic paper. It is a documented, modeled, publicly acknowledged concern at NOAA. The agency has said so in budget justifications submitted to Congress. In those documents, the language is careful, but the meaning is not complicated. DSCO-VR is aging, the backup systems are less capable, and there is no funded successor with equivalent magnetometer capability in operational orbit. Congress received those documents. Funding for a DSCO-VR successor has been proposed, discussed, and deferred multiple times across multiple budget cycles. This is not new information. It has been available to anyone willing to read federal agency budget justifications, which is a very small number of people. In the meantime, the satellite keeps flying, the solar cycle keeps climbing, and the CMEs keep coming.
Okay, so my kitchen.
And that's what I was trying to give you as an introduction to what I'm going to show next, because as what he said, and not me, there's an 11-minute window warning between a major solar storm, and we're not perfect over here, but what we can show you is a lot more time than 11 minutes, and I can prove it. But first I got to get over here to my little table, now that I got that part of it down, to my research that I've been doing with everybody, and I'm doing this so I won't have to put the plastic there, because I know last presentation plastic was making it hard to see. This is the chart, the basic chart that I already showed Colleen about how I do the layout, and all this. And you notice all the ones going this way and all of that. This looks confusing because this is my research paper that I was doing to show you what I'm going to show you next. But this is a solar chart on how you can predict solar storms way in advance into the future, and you could even find solar storms way back into the ancient past. But let me show you in a second here. First I gotta do my order right, because if not I'm gonna get lost and then I'll be fumbling around. So like I said, this is the solar chart, my research chart for what I'm going to show next. And this is the chart that is used for predicting solar storms. And now I'll go into explaining, that with a similar chart that I have here. Oh, here we go. Okay, I got the right one. Okay, let me take it out because it'll be too reflective otherwise.
Nice t-shirt, by the way.
Oh yeah, and then what got one's saying? Sacred, holy, holy shirt. Okay, now this is the other one that doesn't have all my scribblings on it, because my scribblings was letting me know about how to make the chart that I'm showing you right here. This one serves two purposes. But I'm going to only show one purpose, because it's also used for another purpose, using 13. But we're using 11, for predicting solar storms. And why 11? See, if you go here to there, that's 9, and then 10, 11. 9, 10, 11, numerical order.
And that's your shortcut, because otherwise
9,
you'd be
10,
going that slow.
You'd be doing that all day.
Yeah.
I'm just showing the shortcut how to find the numerical order of how, this is operating using the 11 here. And using 11s, and like I said in the past presentations, how I use the numbers and, to make these little sun marks in there, because you got to do it a certain way, because if you don't, you're going to miss a solar storm.
So check out the last presentation.
Yeah, our past presentations will explain more of that in detail.
The last one, yes.
So just giving you a
the last
little
three, I should
refresher.
say, because the last presentation was actually three videos. The last 3 videos.
Okay, now with that understanding, I'm going to show you how I predict what is coming by using 2026, because that's what I've been doing the presentations for the last month and a half. As a matter of fact, people have been probably wondering, why are you doing 2026 as a presentation for a solar storm? It's just not any solar storm. It's part of the final solar storms before the big one occurs. And I'm going to explain how I come up with, the years for these solar storms. And it's not, like I said, it's not really that complicated once you figure it out. It just takes using this here, really. And then, so, like, what I'll do is I'll start with something like I said, like I'm saying, 2026. How do I know that 2026 is going to be a major solar storm? You see this line that's right here? That goes all the way there. I'm going to show you why that line is there when I put this ruler here. This is all identifying in the ancients' way of solar storm number 9. See? 9, 9, 9, 9. All the way. Do that for 8 too. 8, 8, 8, 8, 8. Solar storm 8. Solar storm 7. See how they work? Mm-hmm. So they're, it's all in a line and with the same number.
And the layout is similar to the 260-day calendar, just like how you read it.
Well, it's based on it, really. Yeah. Everything on here is based on the 13 and, and 16 and so forth. Oh, no, back to what I was saying about 26. Okay, now you see all these numbers on here. I started the numbers down at 18, 58, 59.
And that was the Carrington event.
1948, 1949, which is the midpoint of this whole thing here. And then you get 2038, 39, which is when it repeats itself coming back to here because it skips in the middle. So this hits the Carrington event. There's a moderate storm, and then another Carrington event will occur in 2038, 39. And that's, what kind of this first square is about here. That's why I call it solar maximus.
Well, also the 2038, 39 part of that is because the year begins in November. On the indigenous
and to the following
New Year.
November, because of the annular stars, the Pleiades, and how we count our indigenous year from that
from November to November. Yeah. So there's only really 3 months.
Indigenous New Year, basically.
Yeah.
So now you see what I'm doing with the ruler. All I'm doing is going from that corner to this corner with all those same numbers. I'll put it at 1 again, and then I'll put this one on about 9.5, and then you'll see, and I'll loon it so you can see the line that I'm showing. It's right there, and this is the rule I used to create this line. Now, how do I know it's going to happen in 2026, which is this year, that was as an example to show you how this chart works? It's really simple. You go through all the charts and you find 2026.
Oh, the year.
Mm-hmm.
Got it.
First, you got to find the year. And then how do I know it's going to be a storm? You follow these 9s. That 9, nothing there. That 9, nothing there. Wait a minute. That 9 has a dark circle around its sun. What a? It's 1906. What happened in that 9? The San Francisco earthquake, which was a severe earthquake that happened in 1906. So you go down here, okay, and then you go over here, okay, and then you hit over here in 1966, and there was a geomagnetic storm in May that happened that was so severe that broke down, it caused the radars to black out, and it almost caused a nuclear war because the Russians actually thought America was going to go to war and knocked out their radars. And then Americans thought the Russians knocked out their radar, and In reality, in 1966, the storm was so severe it knocked out everybody's radar. And so we barely avoided a nuclear war in 1966 because of that geomagnetic storm that occurred then. So now what does that tell me about 2026? There's a geomagnetic storm that's going to occur that can cause electrical problems on Earth and our energy grid because it's geomagnetic. And what it's going to be connected with, it's going to be connected to an earthquake, which is this number 9 over here, which happened to the San Francisco earthquake in 1906, which is that 9, which is going to go down here to 2026. In other words, there's going to be a geomagnetic storm that's going to occur along with an earthquake in the year 2026. What just happened? There was a magnitude 7.5 earthquake in Japan that was caused by a geomagnetic storm. And what happened after that? There was issued a tsunami warning. Exactly what we told you guys 2 months ago in the beginning of these presentations. We're trying to get this out there just in case there's a severe earthquake that might cause a severe tsunami, and we could save lives if we get this out there ahead of time. Now you see how this works? Geomagnetic storm, earthquake, and they're going to be all combined in the 2026 geomagnetic storm because there's that sun blackened. All my ones that are blackened are the ones that are, going to be coming up in the near future. This one's now, so I don't have to worry about the near future. But now you can see how that's connected. And why is 2026 important? There's another important, because there's numbers that important to us is 13 and 8, which is, half of 16. Now watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Solar Maximus. There's that number.
2038, 2039. Solar Maximus.
So now you can see how that's kind of connected now. Now using 2026 as an example, and then showing how the geomagnetic storm is connected to the earthquake that's connected to where we're at right now, and how it's connected to the end of the cycle here. That's why I was showing that in the presentation, like any other good Maya astronomer would have done in ancient times. You got a 13-year window of warning to be ready for that. Doesn't that beat 11 minutes? That's my main point about doing this presentation.
Well, I was going to say the other thing is, in the Codex Telurianus-Rimensis, there's a picture of like people in the water, on that for this year, I think.
26, 27, Trump's going to start a war, and that war represents a dead eagle that's in there, and their eyes are closed, and they're all dead warriors because they went to a war and they're dead. What else do you want to know?
Yeah, that's super interesting. And then they have in this, on the Codex Telurianus-Rimensis, which is the Aztec codex that was pulled out of a fire in one of Hitler's book burnings. That one was a big flame, a torch, a big flame coming from the sky and hitting the earth.
That's called World War II. But anyway, back to what I was showing here with this example. 2026, where it's this example here. Now I'm going to show you two more other ones, and so you can figure out where I'm going with this thing here. This one is kind of connected more along the lines with this storm that's here in 2026. There's another one that's going to be happening in 2028. See, GMS 2028. Let's see what it's connected to. See that one is always a guaranteed solar storm. One. Okay. It hit Quebec in 1988. What happened in Quebec? The energy grid went down, and it took out the whole country's electricity for umpteen amount of time, and it took hours and hours before they could get their electricity back on because it took the entire energy grid out. So now I know it's going to be connected to that. And what else is up here? Geo-Magnetic Storm in 1958 in February. Okay, and so how severe is this storm in 1928 going to be? It's going to not be the solar Maximus, but look what it's connected to. It's directly in the same 1.
So it's not going to be like the biggest,
The big one yet.
but it's still going to be probably pretty big.
Probably a moderate extreme, because we're not to the Maximus yet. But look how it's connected. See now how that's connected. Now it tells me it's going to be a strong. It's connected to the Carrington event, and it's geometric storm, and that's going to take out the energy grid. Mm-hmm. See, I already know what's going to happen in 2028, and it's also Keaton 13, Ahau, and the Maya, Chilombalum, Chumayel. So now I showed you what's going on with this one, and now I'm going to show you from 2028 to the next storm. See, if you notice where I put them on, I put this little red, square here, and then there's two solid ones that are here that are connected to these. So that's 2028. I already told you 2026. Now we're going to 2032, which is the other predicted solar storm that's going to occur in the future. And what's going to happen in 2032? Oh, Halloween geomagnetic storm. The Halloween geomagnetic storm was so severe that it took out some Japanese satellites and also screwed up some of the energy grid. So this one's going to have to is connected to screwing up the satellite systems that are in orbit.
That was the year 2002.
See what 2000, and then how that line and 555 is connected to 2032. And the three lines I did here are just the lines for the upcoming solar storms that I'm going to be focusing on, because the next one is in 2028. That'll be the next one I'll be focusing on. But each of these, you can do the same thing into the future or into the ancient past, because this chart right here can be utilized by switching the numbers, if you know the math, to the numbers here to the next cycle, either in the past or to the next cycle going into the future, and it'll still apply, which is really kind of weird, because this is the device that the ancients were using to predict these solar storms that were going to be coming up in the ancient past. And look, it's not based on electricity. It's not run on a computer. It's not even tied to anything magnetic. But guess what? This little piece of paper could save your ass.
Wow.
Because no computer or anything in the future can ever help you, because if the energy grid is out, nothing's going to run. And if you were smart, you'd get ready for 2028 and 2032 now, because they're only going to give you 11 minutes in the future to let you know. That's just enough time to get on your knees, to say your Hail Mary, put your head between your ass, and kiss it goodbye. That's about 10 minutes right there. And on the 11th minute, it happens. So, I'm giving you a heads up that your scientists are way, way, way behind. I don't know what they're wasting those trillions and billions of dollars on, and when I can show you not only these that are going to happen in the future. I go back to all these solar energies, back to what took down the Clovis man, the solar storm that took down the Denisovans, and the solar storm of 41,000 BC that took out the Neanderthals. And now here we are at 2039.
And you use this chart to figure that out, basically.
Yeah.
Wow.
I mean, people poo-poo us off, but we're pseudoscience, but there's the proof.
And these numbers all came from the Mayan Chumayel book of the Chilombalum, the Mayan book of prophecy.
And now that I got that out of the way, because I think I explained it right, I'm going to give you a preview of the next presentation, but that'll be the next one because these subjects are, only could scare you one topic at a time. Colleen wants me to scare you out, all the topics.
You mean like talking about Chicago?
Yeah. But everybody had to put their depends on. But before you turn it off, I'm going to show them a quick preview of what my next upcoming one is going to be. What I showed you on here is using 11.25 to figure out these solar storms. But on the next presentation, what I'm going to do is predicting UFO arrivals by using 13 on the same chart. And when you use 13 on here, it'll tell you the exact time when there's going to be contacts and when there's going to be UFO waves and when they all come to one common endpoint. But that'll be for the next presentation because, one heavy topic at a time. Because these yellow squares and the orange squares, that's a preview of how to predict when the star people arrive. When they show up to make contact and when they show up in UFO waves. But that'll be for the next presentation. And that's the yellow and the orange and using 13 to predict UFO arrivals. You'll be amazed because when I do the next presentation, you'll be surprised on who's connected and how they're connected. But that's on the next presentation. One scary subject at a time.
So thank you everyone for tuning in. And
From the boogeyman and the boogie woman.
have a good day.